Hey everyone, welcome back to what is the last and final video for circular motion. And so in part A, we had looked at finding the horizontal distance that a hammer is going to travel if you were to spin it at a horizontal speed of 20 meters per second and toss it. And we found that it would travel a horizontal distance of 9 meters. So in part B here, we are going to find the period of rotation of this hammer. So this is the how long it takes us to make one complete spin in preparation for throwing this hammer. So here we're looking for how long it's going to take to complete one full spin before we launch that hammer. So if you were to complete this on your own, you might want to cycle through, well, what do I know about period? You know that your period is equal to the amount of time it takes to complete one cycle. And so first of all, we don't know the time. Nor can we really calculate it at this point. I know that in part A we did calculate a time, but that was related to the time when you spun the hammer, and basically when you threw the hammer, and the amount of time it took for it to hit the ground. So that's not the same time that we're referring to in this exam, or this part right here. So we can't use this formula. So hopefully your brain is then asking, okay, well, what other kind of formula do I know that works with period? And that, in fact, is our speed equation for circular motion. So it's 2 pi r divided by your period. So that means we need to know our speed, and we need to know the radius that we're throwing this hammer in. So the speed that we're going to use is actually that 20 meters per second that we had initially launched our hammer at, that we looked at in our first example. That there, if you guys just remember, is, when you launch it, that in itself is an instantaneous speed, and you could consider as being a tangent line that's being taken from this circular motion. So we can use 20 meters per second for our speed. And then the other thing that we need to know is our radius. And if you go back to the question above, we were told that the hammer was spun with a 2.4 meter radius. Alright, so this is actually all that we need to know to solve for our period. Alright, so our speed there was 20, and then we had 2 times pi times the radius of 2.4 divided by t. So what we can do is, if we were to plug this to our calculator, we would get a decimal value when we plug in pi. So what I would actually recommend is first solve for the variable t. So write this 20 over 1, then you can cross multiply to solve. So you have 20 times your period times 2 times pi times 2.4. And I want to get that period by itself, so I'm going to divide by 20 on both sides. And essentially what I have is your period is equal to 2 times pi times 2.4, all divided by 20. So I prefer that you leave the actual calculator work until this point here, just because then we don't have to worry about any rounding errors and writing down a bunch of numbers. And it's also kind of nice to help us keep track of sig figs at this point, just because there's a lot going on. We have well, maybe not that much, but we have this 2.4 we have to consider, and the 20. So it actually does kind of help keep things a little bit nice here. So if you plug it into your calculator, go 2 times pi times 2.4, and then all divided by 20, we will get, in our calculator, this is rounded here, we have 0.7540. And then just accounting for sig figs here, we had 2 sig figs in both of our values, so our answer is going to have 2 sig figs as well. So our time is 0.75. And if you're not sure about what your units are for, sorry, this is your period, but in terms of the units, here we look at our speed, which was given in meters per second, so our units here will be seconds. And so once again, I did mention in the previous video, but in terms of your period, you can just leave your time, or sorry, the units as seconds. We will assume that that is seconds per cycle, okay? So then just to answer this using a sentence, we would say the period of the hammer is 0.75 seconds. So that they're just saying it would take, you know, about 3/4 of a second to complete one spin. Alright, so as you guys can see, the rest is on your own, so please take some time to try out those questions. You do have the answers at the bottom of your worksheet. Solutions are online as well, and make sure if you guys have any questions on, you know, anything from this video or any of the videos, and even the on your own, just feel free to shoot me a question or a message on Remind 101, or we can even, you know, schedule a Zoom to talk about what the heck was going on in these videos and these questions, okay? Well, thank you guys so much for watching.